In this video, we're going to look at the differences and the definitions of accuracy and precision. Accuracy refers to the closeness to the correct or accepted value. So in a case of an answer being accurate, it is very nearly to the true answer. If you're measuring something and it's 3.5 grams, and when you measure it, you get the 3.5 grams, that is accurate. You also can be within a range of numbers and still be considered accurate. Precision, however, is where you are able to repeat the answers more than once. For instance, the definition here says it refers to the closeness of a set of measurements of the same quantity made in the same way. If you're measuring a particular sample and it has a volume of, when you read it the first time, it's 25.0 milliliters, and the second time you read it, it's a second sample, you have 25.1 milliliters, and the third time is maybe 24.9. Those are all very nearly the same answer, and they would be considered to be precise or have good precision. In this image, you can see that there's three pictures replicating accuracy and precision in three different versions. In this in the first example right here, you can see that all three of the arrows are in the center of the target, and that would be the ideal. That is both accurate and precise. You have repeated it more than once to get the same answer, and the answer is on the true, correct value, so in the center. In the second image, all three of the arrows are in that one quadrant, if you will, the bottom center almost, and they are all very nearly the same. So you have good precision, you've repeated the answer, but the answers that you came up with are not exactly correct, so you have poor accuracy. In the third example, you have a scatter. You have all three of your darts are all over the target. You don't have good precision. You weren't able to replicate it. You weren't able to get the shot in the same spot. And you do not have good accuracy. None of them landed in the center. You could have landed one in the center and still would have had poor precision because they're all over the place. A way to quantify or measure your accuracy is through the calculation of a percent error. And in labs, we're asked to find percent error frequently. And you do that, you calculate it by comparing the accepted value and the experimental value, indicating how close to the correct answer you are. Two terms there. You have both the accepted value and the experimental value. The accepted value is usually given or is something you look up as a known value that is the accepted to all people version of the number that you're measuring. And an experimental value is something that you calculate, you find in the lab, and it is something that could be different depending on the situation or the person measuring it. So here's the equation for percent error. You can see percent error is replicated or shown this way, and it is measured by taking the exact or the accepted value minus the experimental value divided by the accepted or the exact value again. You take this whole thing times 100. Something to keep in mind, you see that there are absolute values there on the side. This value is always going to be positive, so no matter how you subtract them, they're going to come out to be a positive value. You report a percent error as a positive overall answer. So again, it's the accepted minus the experimental, all divided by the accepted. The whole thing is positive, and you multiply by 100. Here's a sample problem to work through. The sample says a student measures the mass and volume of a substance and calculates the density as 1.40 grams per milliliter. The correct or accepted value of the density is 1.3 grams per milliliter. What is the percent error? So to find our percent error, we are going to take and we're going to subtract our accepted, which is this 1.3, minus our measured value, and then we're going to divide by the 1.3, the accepted again. We are going to make this be in absolute values, and then we're going to multiply by 100. So if you followed the equation on the previous slide, this is where the numbers go. When you calculate the math out, you get an answer of 7.7%. error. So that means that your answer of 1.4 was 7.7% away from the real value of 1.3. The lower this percent error value, the more accurate your answer is, and the higher, the further away from the true value you were.